Math 3, Unit 10, Whiteboard Review. Find sine of 63, cosine 63, and tangent of 63, and then solve for x. The first thing we need to remember is SOHCAHTOA. And so therefore, when we are finding sine of 63, opposite of 63 is x over the hypotenuse is 15. If we want to then solve for x here, we would just multiply by 15 to both sides. And so x equals 15 times sine of 63. For cosine of 63, so cosine 63 equals, adjacent is 7 over hypotenuse is 15. And on this one, if you notice, there's no x here, so I can't solve for x, so cosine is not going to actually be an answer. This will be a multiple choice question on your test, and so you're going to be going through each one and figuring out which ones are true and false. So cosine cannot be solved for x, and so therefore it's not going to work. The last one I have here is tangent of 63, and tangent is opposite, which is x, over adjacent, which is 7. And to solve for x, we then multiply by 7 to both sides. These eliminate, and we get x equals 7 times tan of 63. And so those are two answers that will work. Okay, number 2, find a positive and negative coterminal angle for 210 degrees. And so coterminal angles mean that they end at the exact same point. And so to find a positive coterminal angle, we just want to take our 210 degrees and go around the circle one more time. So you would add 360 degrees to that, which makes that 570 degrees. In order to get a negative coterminal angle, we would just go the opposite direction. And so we would take our 210 degrees, but I would go negative 360. And when you do that, you would end up with negative 150 degrees. So there is a positive and negative coterminal angle. Number 3 asks for the reference angle of 155 degrees. If I were to graph this, 155 degrees would be in quadrant 2. That is 155 degrees. When you're finding the reference angle, we know 3 things about reference angles. Number 1, they're always positive. Number 2, they always go to the x-axis. And number 3 is that they are always less than 90 degrees. The reference angle is the angle going down here, which is this space right here. So all we're trying to figure out is what is the degree between the 155 degree that goes to the 180 mark. And so I end up going 180 minus 155 to get 25 degrees. So my reference angle is 25 degrees. Okay. Number 4. If the terminating ray for theta is in quadrant 2, then the given statements are true or false. Okay, so first of all, we're talking about quadrant 2. So if we go ahead and draw our little coordinate plane, this right here is quadrant 2. So we want to figure out what cosine, sine, and tangent all are in this quadrant. And so we know that cosine is negative in this quadrant because cosine is dealing with the x value, and in this quadrant our x's are negative. Sine in quadrant 2 is positive because in this quadrant sine represents your y values, and y in this quadrant is up, which is positive. Tangent, we know, is y over x, and so if you have a positive divided by a negative, that makes a negative, and so tangent is negative. Now that we have that information, right here it's saying cosine is greater than 0. Cosine is positive. The values that are greater than 0 is positive. Is cosine positive in quadrant 2? No, it's negative, so therefore A is false. Here, this is saying cosine is less than 0, which means cosine is negative. Is cosine negative in quadrant 2? Yes, therefore it is true. Sine is greater than 0, so that means sine is positive. Is sine positive in quadrant 2? Yes, that is true. Here, Sine of theta is less than 0, which means it's negative. Is sine negative? Nope, it's false. Here, tangent is greater than 0, which means that it would be positive. Is tangent positive? Nope. So therefore, that's false. And here, tangent is less than 0, which means tangent is negative. Is tangent negative in this quadrant? Yes, so therefore, it is true. Okay, number 5. Find the reference angle for 17 pi over 12. Okay, so we need to, on this one, draw our coordinate plane. We know that a whole circle is 2 pi. And so if my denominator is 12, what would I need on top in order to for it to reduce to be 2 pi? And we would actually need 24 pi. That reduces to be 2 pi. Okay, on this side over here would be 12 pi over 12. And then half of 12 is 6. So this up here is 6 pi over 12. And then you would add another 6 here, and this down here is going to be 18 pi over 12. So 17 pi over 12 is going to be in quadrant 3. So if we were to draw our angle in standard position, it would go there, and that is 17 pi over 12. Well, again, when we're dealing with reference angles, we know that, first of all, it's always positive. It's always going to the x-axis, and it's always less than 90 degrees. So in this case, 90 degrees is actually 6 pi over 12. So we know it's going to end up being less than 6. And what we're trying to figure out here, this is the reference angle going to the x-axis. How many does it take to get from 12 to 17, or you can think of 17 to 12? Well, that's 5. So 5 pi over 12, that is the reference angle. Okay, number 6. This says solve for theta, such that 0 is less than or equal to theta is less than or equal to 360 degrees. So all this means is that they want to know the angle that's between 0 and 360 degrees. A couple things to think about here. First of all is that right now this is saying sine is positive. So if we're thinking about our coordinate plane here, or our unit circle, where is sine positive? Well, we know that sine is dealing with the y values, and so y is positive in quadrants 1 and 2. So that means I'm going to have a value that gives me y is root 3 over 2 in both quadrant 1 and quadrant 2. And this is where your unit circle is very helpful, and you should already have this filled out. And so we're looking in quadrants 1 and 2, where is y root 3 over 2? And so if you wanted to, you could actually label all of your coordinates if you wanted to, x and y. But here y is root 3 over 2. And so we're talking about degrees, and so therefore one of the degrees is 60 degrees is where y is root 3 over 2, or sine is root 3 over 2. And then in quadrant 2, again, we're looking for the y value where it's root 3 over 2, which is right here, and that is 120 degrees. And so those will be my 2 answers for number 6. Number 7 asks you to convert 5 pi over 12 to degrees. And so if you're converting to degrees, you want to get rid of the pi, which means you're going to multiply by 180 over pi. And you will notice that the pi's cancel out. And then let's check to see, can 12 go into 180 evenly? And so if you got out your calculator, you could go 180 divided by 12. And it does reduce to be 15, and so I can reduce this to 1 and this to 15, and so we end up with 15 times 5, which is 75 degrees. And so when we convert 5 pi over 12 to degrees, it's 75 degrees. Number 8, sketch the angle in standard position. So here I have a negative pi over 4. So if I were to draw this, I would first look at my unit circle and see where positive pi over 4 is. And you can see here that pi over 4 is at 45 degrees in quadrant 1. And so if I'm going negative pi over 4, it's going to go negative 45 degrees, and that's going to go into quadrant 4, which is at this point right here. And so if I'm drawing it, it's going to be in quadrant 4, and that'll be labeled as negative pi over 4. The next thing they ask us here is, what is the reference angle? Well, again, the reference angle always goes to the x-axis. It's always positive, and it's always less than 90 degrees. Well, in this case, the reference angle is going to just be pi over 4. It's that same distance. The next thing that they ask us to do is find a positive coterminal angle. Well, for a unit circle here with pi over 4, if my denominator is 4, we want this to end up being 2 pi. So in order for it to reduce to be 2 pi, we'd have to multiply 4 times 2, which gives us 8 pi. So that reduces to make 2 pi. You could label the whole circle if you wanted to, 4 pi over 4. This will end up being half of 4 is 2 pi over 4, and this is 6 pi over 4. And I actually wrote the positive instead of the negative, but either way, it's fine. If you're trying to find a positive coterminal angle, though, we, instead of adding 360 degrees, we want to add 2 pi because we're dealing with radians. And so we end up taking negative pi over 4 plus 8 pi over 4, and you end up getting 7 pi over 4, which would be a positive coterminal angle. A negative coterminal angle, same thing. Again, we're dealing with radians, and so you would subtract 8 pi over 4, and we end up with negative 9 pi over 4 would be my negative coterminal angle. All right. Number 9. Sketch the angle in standard position. So we have 410 degrees. We know 410 degrees is greater than 360 degrees. And so in order to draw this, I would first start by drawing a whole circle around, which would be my 360, and then I need to figure out how much is left. So if I subtract 360 from here, I am left with 50 degrees. And so 50 degrees would be in quadrant 1 still, and then we would label this as 410 degrees. The reference angle, again, we know is always positive, always goes to the x-axis, always less than 90 degrees. My reference angle is this little piece right here, which we know is actually 50 degrees. A positive coterminal angle is, I'm going to have to make this into 2 videos.